trying to keep these seminars or webinars to 30 minutes to make them easy to fit into your schedule and be respectful of your time. So, you know, I'm really long-winded, so I'll do my best to be brief with announcements and that we have to share and my intro for our speaker. So first off, thanks for joining us today. Second, we have more upcoming seminars on the schedule covering a variety of topics. So please visit the HESCO website at hesco-mi.com/news/webinars, or if you just go to the main site, you can get there. That has links to what's coming up and when and how to link to it. Third, if you need PDHs today, see we have a good amount of consultants here. Please go ahead and email me or Kip or Carrie. We can get you a PDH certificate real fast. And finally, this will be recorded, so it'll be available for download or reference it later. With that, I'm pleased to introduce our speaker today. His name is Josh Gable. He's from Centrisys. He's a degreed environmental engineer from, well, educated at Wisconsin, so go Badgers, Kip. He did a stint for a few years as a consulting engineer, then joined Centrisys in 2010, where he's learned from the best in the decanter industry and spent a lot of time in the field applying this equipment to process treatment. He's now our regional sales manager. We've been really enjoying having him in our territory, and he's here today to share their THK sludge thickener technology with you. So please welcome Josh.
Okay, thanks for having me. Hopefully this goes relatively well. It looks like I think I'm showing my video right now. I'm going to turn that off and share my presentation now. Let me know if for some reason you're not able to see it. I think. All right. Just a minute.
I had it, Josh, and then you muted me, and now I've got it back. Cool. I think everyone should have it now.
Okay, fantastic. All right, so we'll begin. If you have questions that come up, we're going to do Q&A at the end, and you can type them into the chat box. So with that said, we'll get started.
Hey, just real quick, sort of a housekeeping thing. If you're not used to GoToMeeting, you may see a ribbon with all of the attendees at the top. You can kind of drag that bar up, and it'll minimize it and maximize the screen that Josh is talking about. And I'll mute.
Okay. So first thing, I will go through a little bit of a background on Centrisys. So Centrisys, as a company, started out in 1987, manufacturing, well, I should say servicing other people's decanter centrifuges. So that was really where we got our start. It was pretty humble beginnings, a couple guys in a garage working on centrifuges. And after a few years, we started building our own equipment and eventually, rolling out new products. And about 10 years ago, we started working and developing the THK product line, which is going to be the main topic of discussion today. We also have our sister company, CNP, which has a number of different technologies you may or may not be familiar with. CNP stands for carbon, nitrogen, phosphorus, and some of the technologies you can see on the screen here include the lip anaerobic digester system, the hydrograv adapt variable inlet structure for secondary clarifiers, AirPrex, as well as CalPrex, which is also a phosphorus recovery technology, and then Pondus, which is a thermal-chemical hydrolysis process. Maybe the newest thing that Centrisys and CNP is working on right now is Centrisys is in the process of rolling out a new belt dryer technology, and you can learn more about that at WEFTech this year if WEFTech happens. Otherwise, I'm sure we'll be finding other ways to get in front of you as things progress. But with that, let's get into the meat of the discussion today. We'll talk about thickened sludge. That's the main thing. A nice thickened sludge picture there. But in addition to that, we'll talk more specifically about the objectives of sludge thickening, existing methods of sludge thickening, and then centrifuges for sludge thickening, and then finally specifically using the thickening series or the THK thickener for thickening sludge. So when we think about thickening sludge and considering what types of technologies we might want to use to do that, or how we want to run the equipment we have, the first thing you need to consider is where is the sludge going? So first potential place that sludge could be going is downstream to a sludge digestion or stabilization process. There's a potential for anaerobic digestion. In that situation, you're going to tend to typically use some type of mechanical thickening equipment. Typically, you're going to go into anaerobic digestion in the 4 to 6% solids range. On the aerobic digester, aerobic stabilization side, a lot of plants don't do pre-thickening. They'll do kind of in situ thickening with by decanting the tank. That's relatively common, but it's not unheard of to use mechanical thickening upstream of an aerobic digester to get more solids throughput through the process, and that definitely becomes more of a commonplace occurrence the larger the plants you have. The second thing the second situation you might run across is downstream sludge dewatering. So you might be thinking, well, why would you want to thicken upstream of dewatering? Well, this really only makes sense if there's really large volumes of sludge, and it's most common in situations where you probably don't have anaerobic digestion or significant sludge stabilization going on. But basically, there is some benefit to pre-thickening, even if you're using a centrifuge for dewatering. If the volumes are big enough, you can reduce the capital cost of the installation by pre-thickening potentially, and also operational costs can be reduced to some extent by pre-thickening the sludge. So if you reduce the volume going to dewatering, you're obviously going to get higher throughput of this through the system, but also there's a potential to actually save money on overall power consumption and polymer consumption. And then the final kind of use case would be for land application of biosolids. So this is relatively common in the upper Midwest currently. Obviously, you can see the tractor there knifing biosolids into the ground. So that's something a lot of folks do, and that equipment can handle some probably cake in the range of max 6 to 8% solids, and I think the actual percent solids it can handle is probably a little bit equipment dependent, but that's commonly what we'll see. All right, so now we'll talk about the key objectives of thickening. So regardless of where you're going with the sludge, really the key objective is going to be producing a consistent product, and doing so, while maintaining a good capture rate, what's good for your plant. That target number might vary for both, but ultimately keeping the process consistent and reliable is the name of the game. And then once you've kind of dialed in where you're trying to go in terms of cake thickness, the secondary objective is going to be basically trying to make that process work at the lowest cost possible. So minimizing the polymer that's utilized, minimizing the time and money that's required to maintain and operate the equipment, and minimize the power consumption. And I did rate, those are ranked in my opinion, the most important from a dollar standpoint. So polymer is normally the biggest cost associated with operating solid liquid separation equipment, followed by that operation and maintenance costs, and then followed by power consumption. All right, so now let's look at different methods for thickening sludge. I like to break it into two distinct categories. There's the filtration-based separation, and that's really where you've got basically a screen, and so you've got a generic screen, and then you've got each, obviously the screen's got holes in it, and the holes have a specific size. So particles that are bigger than that hole are going to get, they're going to get rejected away, and the particles that are smaller than that hole are going to go through the filter. And so this is really the basic principle of your gravity belt thickeners, your rotary drum thickeners, etc. In wastewater, we're using this with some type of a polymer to make the process work. On the other hand, we have the Stokes-based separation. The idea here is that it's not maybe 100% accurate in terms of the analogy, but I'm calling it that because really the key things that drive the process are the size of the particles, the diameter of the particle, average particle size, and then also the density of the material. And so it's really based on sedimentation, and the bigger the particle is, the faster it's going to settle. The heavier or more dense the particle is, the faster it's going to settle. And so looking at the different technologies that fit into those categories, again, filtration-based, that's going to be your gravity belt thickeners and rotary drum thickeners. On the Stoke-based side, you've got gravity thickening, which is, Stokes-based separation in its purest form. Dissolved air flotation, I put in there as well. Again, it's not exactly a perfect fit for Stokes' law, but at the same time, the general same rules apply. The bigger the particle size is going to be, the faster that material is going to separate away from the clean water. It's just that in the case of a DAF, gravity is more or less reversed due to the fact that you're saturating the water with air. And then the other one that fits into this category as well is the decanter centrifuge. And so the decanter centrifuge, again, is applying the, basically Stokes' law. The bigger the particle, the faster it's going to settle. When we look at the two different strategies in terms of practicality, the biggest difference is, first of all, filtration-based separation processes require polymer in order to work. Really, if you don't add polymer to these processes, you cannot make the process work for, biological sludge. Because you're using polymer, the capture efficiency is going to be very good. And generally, if you want to get a thicker solids, you can add more polymer and you can get it higher. One of the downsides is that it will require, these technologies are going to require continuous wash water to keep the screens clean and keep them from blinding off. Another positive is that they don't typically require much power input. On the Stokes-based side, gravity thickening, DAFs, polymer is not required. So the processes generally are going to work fairly well without polymer. The better the settling characteristics of the sludge, the better the process is going to work for a given flow rate. But you can add polymer to these processes, and that's going to improve the throughput, improve the capture efficiency, and potentially improve the thickness of the cake. Additionally, they don't typically utilize any type of wash water. Centrifuges also fit into this category. Again, like we previously said, the one maybe distinguishing feature here is it's going to be a smaller footprint generally than the other, like a DAF or a gravity thickener. Additionally, you don't necessarily need to have you don't need to add a lot of polymer to get the cake thick. So that's probably another key distinguishing feature from centrifuges versus the other Stokes-based technologies. So let's dig into the centrifuges a little bit. There's really two key components that comprise a centrifuge. So there's the bowl, and then there's the conveyor or scroll, which sits inside the centrifuge. I'm not going to spend a lot of time on how the centrifuge works in the interest of time, but we'll spend a fair amount of time distinguishing the Centrisys THK centrifuge from this standard design, so I'm going to spend a little bit of just a quick little background. So the outside of the centrifuge spins at high G's, 3,000 G's, let's say, and the inside of the machine, the scroll, spins at a slightly different speed. As the sludge comes in, the screw pushes the solids out, in this case to the right, and it comes out here. The clean liquid comes out on the other side. So this basic principle of operation is going to apply for both dewatering and thickening. Now, to make this process work for sludge thickening, you're going to modify the machine a little bit, potentially, but generally this same design is going to work pretty well, just as is for thickening. So now I'm going to contrast that to our thickening centrifuge that we've developed, the THK series. And we'll start out with a video that just kind of walks you through step by step the differences. So Centrisys centrifuge is shown here. This is our standard dewatering design. Most dewatering centrifuges can be used for thickening, as I previously said, but normally some modifications are made. The key modification is this baffle disc. This helps to increase the process volume of the system to some extent. However, it also limits the capacity, and you have to compensate for that by increasing the scroll speed to push material out of the machine faster. It can also be a little bit unstable to operate this way. By contrast, the thickening centrifuge is designed specifically for sludge thickening. The conical section has been completely eliminated, so that's shown on the bottoms of the screen here. The cylindrical length has been extended, again, maximizing process volume. So both of these things help increase the capacity of the machine. In addition to that, there is an air injection coming in on this left-hand side of the machine, and this helps to control the solids concentration coming out in the cake. Because of the bigger process volume, less polymer is required to run and thicken sludge than a conventional centrifuge would require. And this video is showing in the animation that if you reduce the polymer in the conventional centrifuge to the same as the thickening centrifuge, that the centrate is going to get dirty, as you can see on the top side of the image. All right, so that is a nice little marketing video that Centrisys has put together, and it's a good comparison. It is a little bit of kind of a lot of information in a short amount of time, so we're going to break it down a little bit. We're going to go back kind of through step by step what the key differences are here. So the key things that are different about the thickening centrifuge again. First of all, we've eliminated the conical section. So this is the THK series centrifuge versus a conventional dewatering centrifuge. Conical section is gone and it's been replaced with more cylindrical section. Additionally, where the liquid, centrate over here, solids over here, come out of the machine, this is closer to the center line of the centrifuge than with a conventional machine. That's important because first of all, again, it increases the process volume, but also the closer you discharge your liquids to the center line of the machine, the more energy efficient it's going to be. And ultimately what that means is you're going to get more capacity through the centrifuge of the same sinus diameter as you're going to get more capacity through a machine of the same size as compared to a conventional machine, which means, again, more energy efficient and also less wear intensive overall. The next thing that we did is we added polymer injection to the inside of the machine, internal polymer injection. So this is important because, again, we don't necessarily have to use polymer to make this process work. But if we want to, I'll put it in this context. So our THK 200, smallest unit, runs at 100 gallons per minute for, you know, an SVI sludge of, let's say, 125 without polymer, and achieves maybe 95% capture, 6% solids. But if you want to take that same machine and process 250 gallons per minute, you're going to have to use polymer to compensate for the throughput, and by, you know, making the particle size larger and getting the stuff to settle out faster. So we could accomplish that by adding the polymer into the sludge upstream of the machine. However, that's not the most efficient way to do it, because a lot of the solids coming in are going to settle out on their own, even at those high flow rates. So by adding the polymer internally, we're able to specifically target the fine solids that aren't settling out on their own and capture them, get them to drop out before the centrate leaves the machine. So more efficient means of using polymer, and it allows us to achieve higher throughputs at higher or at better centrate capture efficiencies, and also while maintaining the same polymer dose. And the final thing is this injection of air into the machine. So on the left-hand side of the machine, we're adding compressed air in. It's coming in this disc here, and as the solids come around the disc, the air gets added in, and it actually helps push the solids out. And so what this is doing is really adding a layer of control for how thick the cake is going to be coming out of the machine. So the more air you add, the faster the material flows out of the machine, the thinner the cake is going to be. The less air you add, the slower the solids are going to leave the machine, and the thicker they'll end up being. So if your solids coming into the process are changing a little bit day to day, you can use this air to adjust that. So if maybe on a typical day you're at 1.3% solids, but you know today is not your typical day and it's 1.5, you can add additional compressed air into the machine and help float more of those solids out so that it doesn't get too thick to pump. All right, so as I said, this technology was really started a little over 10 years ago now. I think we first started development in 2008, 2009. The first installation was in 2011. So I wanted to walk you through some of these installations. Most of them are in the Midwest, and just kind of show you some of the different installs, and then also make comments on some of the things we've learned as we went along here. The data is given below, and I'm not going to read through all the data because as I go through 5 of these slides, you'd probably get a little bored. So well, I'll let you read that part of it. But this is the Kenosha treatment plant in our hometown, Centrisys' hometown, Kenosha, Wisconsin. So initially they put in the first THK thickener ever in 2011, and it was installed and it replaced 4 DAF basins. And so that was kind of impressive in its own. And you know why that was important is, number one, it saved them from having to rehabilitate that DAF building. There was a lot of work that needed to be done to make it operable for another 20 to 30 years. So it was good timing to replace it with a new piece of equipment. And they now have the flexibility with their waste activated sludge to thicken with or without polymer. The data below does show with a little bit of polymer, although they've been toying with the idea of taking a little bit lower capture, like 94%, and running no polymer at all. And so they've been doing different things, but you have that flexibility. A little bit later, I think this was 2015, 2014, something like that, they added a primary sludge thickener. So the machine on the left here is actually the primary sludge thickener, and the one in the middle is the WAS thickener. So one of the lessons learned is from putting a primary sludge thickening machine in is that primary sludge can be a little tricky. When they first brought this machine online, it actually got taken back out of service for a while because it turns out the city had I guess it wasn't a surprise, but their headworks isn't in great shape, or it wasn't at the time. And so they had a lot of trash coming in, and it caused a lot of havoc for pumping to the centrifuge. We had some blockages in the centrifuge at times, we put grinders in, and that helped. But ultimately, things got a lot better when they put new fine screening in on the headworks. And since that time, the machine's been up, almost all the time and running very well. producing typically about 6% solids. Currently, they're not running that machine with polymer either, and they're taking a lower capture rate because they've decided from a cost standpoint it's more efficient for them to, treat that return cycle in their aeration basins than it is to add the polymer. Again, you could add a little bit of polymer. In this case, it might be closer to 3 or 4 pounds per ton, and you could get that to 95% capture. All right, we'll move on. The next plant is Whitewater, Wisconsin. So installed this one in 2017. They had rotating biological contactors, but during this project, they switched to activated sludge. So with the new activated sludge process, they wanted to be able to thicken that material before sending it to the anaerobic digester. Now, the way this is worked out is they actually didn't need to thicken that much volume. So the flow rate that they needed to process the machine was low enough that zero polymer is basically always achievable, and while obtaining 95% capture efficiency, even though the sludge is thin, which makes it a little bit tougher. And then the other interesting thing about this plant is that they're also thickening the digested sludge. So they thicken the wads going into the digester, and then they take the digested sludge and they thicken it again before sending it to sludge storage, as they do liquid land app at this plant. Now, for the digested sludge does not have a lot of large particles, so polymer is definitely required to make that digested sludge thickening process work. And I think they're using, I think it's closer to 8 pounds per ton, but nonetheless, polymer is required in that application. But they, on a daily basis, switch from WAS to digested sludge. Green Bay, Wisconsin, they have existing GBTs. In 2017, we added a THK 600 as it was part of their big plant expansion, where they added anaerobic digestion, sludge drying, new incineration, and lots of other stuff. So the original plan for this machine was to thicken primary sludge at about, I think, an average flow rate of something like 900 gallons per minute. The machine was there, it was running on primary sludge, but we had some consistency issues, and we weren't, ultimately, it was an interesting experience trying to run primary sludge for the machine, let's say. So similar to the things we ran into Kenosha, primary sludge was a challenge because of the trash. That was one issue. Ultimately, the grinder that was in there wasn't cutting the particles small enough, and it was leading up to some blockages in our feed pipe. We redesigned the feed pipe, and we got that resolved. But we were still having issues with the cake being actually too thick to pump, and it was only a problem at times. The real issue was that the feed coming to the centrifuge wasn't consistent enough, and specifically for primary sludge and centrifuges, the higher the variability in the feed coming in, the more variable the cake is going to be as well. So roughly speaking, if you double the feed concentration coming in, you may have the potential to double the cake concentration coming out. And although our air system is designed to accommodate that, it wasn't able to accommodate it enough to eliminate the issues associated with that. So we'd have issues with the cake pumps downstream not being able to pump the material. And so couple of take-home messages from that experience. One is, I think generally if you're going to be using this technology for primary sludge or a co-thickened sludge, the simple way of making this process work reliably is to put a sludge screen in place. And then also, if you are going to have issues with consistency, and then in the case of Green Bay, it was specifically, I think, because they have a lot of industry that is just, they'll occasionally have, it's a paper mill, they'll dump fiber, and then all of a sudden the plant gets hit hard with it. But if you have consistency issues, having some additional equalization upstream of thickening go a long ways as well. So equalization and sludge screening are going to make this work a lot more effectively. And I don't have it up here as another case study, but we do have another THK 600 installation, which is in startup right now. But the initial operation and startup that we've done does demonstrate that having the sludge screen and equalization makes for a very reliable operation. All right, next one is Belvedere. This is a THK 200 installation as well, smaller machines. In this case, a little bit higher throughput per each unit. They only run these machines 8 hours a day, one machine, and they rotate, so they've got a lot of redundancy there. 150 gallons per minute, 95% capture, and they're using just a touch of polymer. Biggest lesson learned here is a lot of attention needs to be given to the cake thickening side of things. We were limited initially in our startup on how thick we could make the solids because the cake pumps were not able to handle the pressure of the thickened cake getting it to the digester, which made for headaches for a lot of people. Us, even though it wasn't in our scope supply, and the contractor and the end user and the engineer, basically everyone involved. So definitely want to put some thought into making sure you understand how to move that solids and how much pressure is going to be present in those cake lines on the way to wherever it's going. Okay, final case study here is the one in your home state in Michigan. This is over in Wyoming. It's a THK 350. We put it in 2019 for processing waste-activated sludge. Of all the places that I've presented so far, this is the only one where we've actually replaced the thickening centrifuge with another thickening centrifuge of a different type. So in this case, they had some older, I think they're like 27-inch, something like that, bird centrifuges. And I believe it was 250 horsepower were the old machines. The new THK 350 has a total installed horsepower of 90. So it was a significant reduction in horsepower, and I believe it was actually they got a grant also for doing energy savings on the project. But I think the projection was something like a 75% reduction in power use. So pretty big. And this machine's been running pretty well and reliably since last June when we put it in. All right, so with that, we'll just go back and highlight a couple of key notes that came out of the presentation today. So filtration-based technologies, gravity belt thickeners, rotary drum thickeners. They provide a high capture and are able to achieve thick cake. However, they do require polymer to work, and they also require continuous wash water. In regards to the stoke-based technologies, gravity thickening, DAFs, and centrifuges, generally speaking, no polymer is required for waste-activated sludge, but polymer is going to improve the throughput of these technologies. In the case of gravity thickeners and DAFs, it'll also improve the cake thickness if you add more polymer. Without polymer, they're limited on how thick a cake they can achieve. For centrifuges, they're going to provide the smallest footprint of the technologies that are out there. And they can typically achieve a thicker cake even without using polymer. In terms of the THK series versus the traditional decanter centrifuge, same basic rules apply for both in terms of you can make the process work without polymer, but throughput's going to improve as you add polymer. The difference is, however, that with the thickening centrifuge, you get a substantial increase in capacity at the same, for the same diameter machine. So if you have a traditional centrifuge of 18 inches, you're going to be limited to 100 gallons per minute. Versus with the THK 200, that's also an 18-inch machine. That machine can do up to 250 gallons per minute. And at the same flow rate for each, you're going to require much less polymer for the THK series versus a traditional decanter centrifuge. So it's more efficient in terms of polymer power and capture and throughput. Lessons learned from our first Midwest installation. The process generally works as we conceptualized it back in 2009. There are some issues with primary sludge thickening and trash. Those things, again, like I said, can be easily prevented, specifically by putting some type of sludge screening device upstream. I know that HESCO's got a good sludge screen option for you if you're looking. And then also, if the feed again with primary sludge, if there's a lot of fluctuation in what can be coming to the thickening process, equalization is something that's definitely going to be valuable. Also, thickening sludge or the thickened sludge and getting it to where it needs to go is always, it seems like no matter which project I've worked on, that's always the biggest concern and question, is how are we going to be able to pump this sludge, especially so for some of these anaerobic processes where now we want to be able to run at higher solids concentrations to improve the digester efficiency, which makes sense, but getting the sludge where it needs to go, that's a key concern that has to be addressed somehow. And in terms of economics, the THK series is going to offer good payback for small, or I should say mid to large size plants on the basis of polymer savings. So, the best way to think about it is if, you're spending, $50,000 or $100,000 a year in polymer on sludge thickening, installing a new machine is going to have a pretty quick payback, less than 10 years, let's say. But when you start looking at the smaller plants, the payback might not be there in terms of polymer savings, but there also is the potential to limit the need. If you don't need to run polymer, like was the case in Whitewater for waste activated sludge, that's a lot less hassle to have to deal with, and so that would maybe be worth the extra money when if you're replacing a piece of equipment that's reached the end of its useful life. So with that, I will take your questions. Please drop them into the comments section and I'll retrieve them.
So while anybody's firing up a question or two, this is Glenn. I just wanted to once again thank you guys for attending today and sharing your time with us. We hope that if you get into sludge thickening applications, we've given you some more really good information to consider. Along those lines, if you don't have a question right now and something comes up a little later, feel free to email me, Glenn, or Kip, and as well as Josh. His information is up there right now. We'll be delighted to get back in touch with you. And then finally, you just want to make a quick mention. Centrisys was talking about their thickening technology. They're obviously also a dewatering decanter manufacturer, and they do service their own equipment as well as other manufacturers' dewatering equipment. They have a huge inventory fairly locally here in Wisconsin, or in the US in Wisconsin. They're close by, and they have a very good service outfit. So Chris Temple is Josh Gable's counterpart in the aftermarket, and we'd be happy to introduce you to Chris if you have any dewatering or dewatering equipment aftermarket needs. I don't know if, let's see, did we get a question up there, Josh?
Yeah, I just got a question, and the question is, what size headwork screening is necessary to eliminate some of the plugging problems experienced on the primary sludge thickening applications? I believe like what Kenosha put in was fine screening. Actually, I don't know, maybe I can sort of pass this back to Glenn. I think what is conventional screen size on a sludge screen? I don't know if you would know that, but maybe if we can't figure it out, we can certainly get back to you. I can find out what the screen size is at Kenosha.
5 millimeters and smaller. And Kenosha was a fairly large screen, and then they went to I believe it was 1/4 inch later. So it's a really good question, and Josh, we'll follow up and get some more information on a recommended primary screen size, headwork screen size.
Okay, we have one more question here. I might have missed it. What are the annual or regular O&M things required for this equipment? Yeah, I didn't get into that in the presentation, but certainly can quick talk about that briefly. On the centrifuges, there's the short-term key maintenance items are going to be greasing the bearings on a weekly basis. The main bearings have an automatic lubricating system, so they're going to grease themselves every 8 hours operation. There's a reservoir which does need to be filled. The larger machines are oil lubricated, and there'll be a reservoir that needs to be refilled likewise. And then there are also drain cans that would have to be emptied with that particular system. That's something you're going to end up doing every couple of weeks. But there's small vessels. It's not an onerous task. Other items are going to be probably once a year. You're going to change the belts on the machine. And then for the scroll drive system, we use the hydraulic scroll drive. So that requires hydraulic oil change once every 6 months or every 4,000 hours of operation. And then also an oil filter change at the same time. And then if you were using another manufacturer's machine, they've got gearbox drives, and rather than changing the hydraulic oil, you'd be changing gearbox oil on a similar interval, I would imagine. Other things, so like a little bit longer term than annually, there's going to be, every 15,000 hours of operation, we do recommend that you pull the rotating assembly out of the centrifuge and send it back to Centrisys to go through and refurbish the unit. That goes for thickening and dewatering equipment. And really what we're doing there, I mean, obviously we're changing bearings and seals on the machine, but also wear protection inside the centrifuge. There are a number of sacrificial components that we put into the machines to take the brunt of the wear and tear so that the actual stainless steel casted parts aren't being worn away over time. And so that those sacrificial components will occasionally need to be repaired. And of course, we're also inspecting the centrifuge for damage at the time. So again, that's something that would happen every 15,000 hours. We got another question here. It says, can the system be used to process septage? I would say potentially yes. I don't know if that would make sense. Depends on, I guess, what your end goal is. If you're actually, one possibility would be if there's a lot of material and trash in there that, or grit and sand, things like that, it may make more sense to use a conventional decanter centrifuge in that application. Just depends. But, if you wanted to use the thickener and your end goal was to try to make a sludge in the 6 to 8% solids or somewhere in there, thickening centrifuge would work. Like we talked about, the main thing would be that you put some type of screening upstream. Looks like for everyone to see, Glenn put a clarification up on the bar spacing for screens. So if you want, you can go ahead and take a look at that in the comments. I don't see any other questions. Give it just a minute here, but again, thanks everybody for joining us today, and thanks for the opportunity to present. Like Glenn said, if you have any questions or need anything related to centrifuges or really solids processing generally, reach out to the guys over at HESCO and they'll point you in the right direction.
Thank you, Josh. Thank you, everybody, for attending today. That concludes the webinar.
All right, take care.